All right. So as we look at the schedule moving forward, we talked about this a little bit last week. And with tomorrow's weather, I think that should be all right. Might be a little windy, but for those of you who...
The theme for tomorrow night's volleyball game will be construction. So get bright.
I'm wearing a hard hat.
Be bright.
Okay, so for those of you who are, let's say, when you drive to school or if you ride the bus and you don't put a sweatshirt on, okay, it's probably going to be a little cold outside if you don't have one. All right, so keep that in mind. So you're probably going to need or want to be able to dress appropriately for that, which means you may want a stocking hat, you may want your sweatshirt or coat or whichever, something to that extent. So what we do with this is, all it says is activity. But what we talked about, not so much last week, but how do we calculate, and maybe we didn't talk about that enough. How can we calculate your horsepower? Well, what do? You pull something. Yeah, you're going to be pulling a sled. So what that means then, in order to do that, you have to know some of these variables. And what that means is, okay, here's the end zone right here. No, you don't have to be writing this down unless you wanted to. So if we really wanted to be specific, let's see here. Well, I think that's right. Okay? Right to left and upside down. There's that organic chemistry coming in handy. Trying to visualize things in 3 dimensions. Okay? So what this means is here's your sled for one person, and here's the sled for the other person. There's a weight on there. And then here's where the person 1, person 2. Okay? Then there's a rope that's tied to that sled. Okay? Now, what happens is, what variables would we need to know to solve for horsepower? Momentum? No. Okay? So we would need to know what this distance is. So by the press box, in other words, PB for press box, that, I believe, is about the 40-yard line. Okay? But we don't measure things in yards. We measure those in meters. Okay? So what that means is, since this is just a little bit longer than a yard, this is 40 inches rather than 36, I think we just throw a number out there and say, by the time you get up to there, maybe 38.75 meters now. Okay? So what has to happen then is we have to have someone with a stopwatch, okay, and who is standing up here, and we just tell them that when you see that person's arm go down, that's when these 2 people take off then, okay? So we know the distance. And you won't know the time until you cross that finish line. In other words, this talking about Christmas. Yeah, he's talking about snow. It's got me thinking about Christmas already. Not sleigh, but sled. That sled has to cross this line, okay? I mean, not that it has to, but we want to just keep things consistent then, okay? So we know the distance. You won't know your time till you pull this all the way across. So then, if we know the distance, 38 I know it's 0.75. We know the time. We'll just say 12 seconds. I don't know. I'm just making that up. Okay? Probably, but I don't think it's too bad. I think someone can probably get this down to probably close to 10, even down to single digits. Okay? So, heck, if I can get it down to 10, you can certainly get it down to 10. Okay? At least I think so, because usually I'll maybe jump in at the end, just for, some people want to do it twice. Okay? And that way people can look at that old guy trying to struggle and pull that sled along. I don't know. So we know the distance, we know the time. So then with the weight and the sled all together, I believe the sled is 21 kilograms. So we would say the mass would approximately be, we'll just say 41 kilograms. Okay? Now we know the mass. Do we know the acceleration? But we can find that. How might that be? What do we know? Because remember, it's tied to this. Okay? So person 1 and person 2. What variable do we know that we need to solve for acceleration? Besides the time. We know the time. What 3 variables do you need to know to solve for acceleration?
Initial velocity and final velocity.
Okay. Do we know the initial velocity?
No, 0.
Is 0. So we do know the initial velocity. 0. With these two, we find the final velocity. Okay. Then with that, we can solve for acceleration, which I'll just say a number from calculations. Okay. Then, well, I suppose if we really want to be specific, we could say 38 divided by 12, which would give us 3.17. 3.17 meters per second squared. Then with these two numbers, what can we find? We can find the force, which means we're going to take that 3.17 times what? Why are you correct?
Because force equals ma.
That's right. So this gets taken times 41. Then that gives you, let's see here, 3.17 times 41, which gives you 120, we'll just say 130, sorry, 130 newtons, okay? So with this number and this one, what can we calculate? Too far ahead. We can find work because we have a force times a distance gives you work, okay? Then once you've established finding your work, what can you do because of that variable? Okay, well, let's look. We've got force times distance divided by time gives you what? Well, don't say it like a question. That gives you power. Once you find that power, you divide by the constant 746. Okay? That will give you your horsepower. Is it going to be a number of 1 or 2 or 3? No. You'd really have to be moving fast in order to get over 1, because we're not machines. We're just not. And even if we would, if we put just very little weights on here, would you be able to sustain that for a long time? I mean, going 3 blocks down the road, you could, but you probably have to do what? Probably have to stop and fuel up. In other words, catch your breath. Then you could take off again. But cross-country runners, we don't stop, do we? We just keep running. Because if we're running, we run like we're late for science, don't we? Then it was just zoom, away we go. Yeah. Yes, that is a T-shirt that we used to have. We run like we're late for science. Yeah. Okay, so this, and the reason that I hope that we like this is you're not just sitting in here looking at things like this. Yes, we do this too, okay? But when you actually look at this, you're getting raw data from that. It's not just something you're doing in a textbook or on a worksheet. You're actually doing this and calculating what we've been talking about in class. So hopefully we can see the value in that. Maybe some people more than others. I don't, you have to decide whether you are one that wants to take value in this. I can't tell you that. I hope you do. That is your own personal choice, maybe. I think that's probably correct. Okay? So we went through that really fast. Is there any questions over this? Hopefully now that we see this, okay, we see the distance. We don't know the time. We know our initial velocity. You'd have to calculate your final velocity. The mass is known. Since the mass is known, we can find the force because we can find the acceleration. And then the force times your distance gives you your work. That work divided by time gives you your power. Then ultimately that power, which is divided by a known value of 746, will then give you your horsepower. Front row, any questions on that? Front row. Okay. Second row. Back row. Okay, so this was no questions then? Okay, all right. So what we need to add then, I'm just going to hit pause for a moment. So we got that wrapped up. There's another formula we want you to write down. So mechanical advantage equals a system's work output divided by work input, okay? So it's very close to a different formula that we've seen before. And that is, depends upon what it is asking. Because this will not give you a whole lot of information because there's only 3 variables. But it's very, very similar to this one. Depends what the question is asking for. Because efficiency then is also work output divided by work input, but we don't know it by that variable, do we? Because in this formula, and I would presume that we all have this wrote down. Because if you don't, you're really making things difficult for yourself. Like trying to throw 5 interceptions in a game and you're still lucky enough to win. We saw that last night, or Minnesota did the same thing, throw 3 or 4 interceptions. They're really making it difficult on themselves to win. They did it, but bad things happen. So with the efficiency formula, what's your question? Okay. What is on top in your efficiency formula? And if you don't know, look, that's why you have a formula sheet.
FR times DR.
Right. So FR times DR is a work output. A work input then. Oops. Which makes sense if you're putting work into a system. That must mean you're putting effort into it. That's why these 2 equations are related, but they're not asking the same thing. Okay? Just like electricity and magnetism. They're related, but they are 2 totally different concepts. Okay? Heat and temperature. They're related, but they're still 2 different concepts. Okay. So from last week, it was something about a lumberjack. what were some of our variables that it says the lumberjack swings with, what were those variables? Does anyone have those wrote down like we suggested that you do?
While swinging an axe.
So he's swinging an axe.
Force is 47 newtons.
Okay, so we'll come back to that. We have 47 newtons. Okay, what's another one? What's the number? Just read the number.
0.11 meters.
0.11 meters. What's another number? 4.18 newtons. Okay, then next one's question mark. Okay, so if my memory serves me right, doesn't it say the lumberjack is swinging with 47 newtons? Okay, so if they're swinging with newtons, what type of variable is that possibly going to be? Newtons is going to be any type of what? It's going to be any type of force. Okay, so if that's the case, again, it's something very similar to this equation. So if he's swinging with this much force, is that an effort force or a resistance force? If he's physically has this axe and he's striking that with 47 newtons, is that an effort or a resistance, you think? He's actually putting effort swinging this axe. So that means this is an effort force. This is labeled in newtons. It probably says chops into the wood with 4.18 newtons of resistance. Does that sound right? Okay, so then this is the resistance force. Then does it say the axe moves into the trunk with 0.11 meters of resistance? Okay, so then that is a resistance distance. So then we want to know this arc that he's swinging with, coming back and going forward. Okay, it's not just a straight motion like this. You're not going to be very efficient when you do that. It's going to be an arc like that. Okay, otherwise, yes, you're going to be there all day if you're just doing this. Some people might do that, but I wonder if I can move that fast enough. Yeah, you can maybe hear that. Okay, so then this must be our effort distance. Now, it's not this equation that we're using. Again, this is related to this one. What equation would we use? Are they all in a straight line? Straight line means linear, which means you're going to have two variables on one side and two variables on the other. So just like what we have here, two variables on the bottom, two variables on top. So that means you would have FE times DE equals FR times DR. And the reason that we know that it's this equation is it asking for efficiency when this lumberjack is swinging his axe. Does it ask for efficiency? No, it doesn't. And we would know that it isn't because it doesn't say anything about an inclined plane either. So you know it has to be this then. Okay, so we have our equation. We have our setup then. Now we just do what the formula tells us to do. Okay, so on the right-hand side of this equation, what is on the right-hand side according to this information? Can be a little more specific than that.
47.
Okay, so we got 47, actually over here, okay, times, we don't know. What's on the right-hand side?
0.11.
And
4.18.
so now, again, we just do what that formula tells us to do, which means 0.11, 0.11 times 4.18 gives you 0.46. But we still have 47 DE over here. Okay? So then how do we get DE all by itself?
Divide.
Okay? So then we're going to divide each side, which means distance equals 0.46 divided by 0.009 meters. Okay? Now you're just going where those numbers are leading you. Okay? That's probably not very far, but that's what the problem has said. Okay? So that's where those numbers have led you. Okay, so as far as our purposes are concerned, you have paper I'm going to hand out here shortly. Some of you are still missing some papers. I put one of yours in the grade book last night, I believe, or yesterday or Saturday, something like that. So make sure you're getting those in, because I have a due date of the 13th over there. I don't believe that is correct. I think on plan book it says the 14th. So I'm going to change that on the board, because that on plan book, if it doesn't say the 14th, we're going to change it to that. Okay, so that's all I have. We will catch up to you next time. I'm going to hand out this paper, and the rest of the time then will be yours. Okay, now I got the papers passed out. So again, we will catch up to you next time.